Welcome back to the Cisco NetAcad CCNA3 Enterprise Networking, Security and Automation lecture series. If you haven't seen my previous lecture series covering CCNA1 and CCNA2, I will leave links in the description for those playlists. I would recommend that you go through the previous CCNA lectures before you move forward with this course. Today, I will cover module number 8, which is VPN and IPsec concepts. The primary objective of this module is to explain how VPNs and IPsec are used to secure site-to-site and remote access connectivity. We will cover the VPN technology, types of VPNs, and IPsec. VPN technology. Virtual private networks. Virtual private networks, usually known as VPNs, are used to create end-to-end private network connections. VPN is virtual in that it carries information within a private network, but that information is actually transported over a public network. VPN is private in that the traffic is encrypted to keep the data confidential while it is transported across the public network. So the term virtual private networks or VPN is used because it is a virtual system, because it uses our already existing public internet infrastructure to communicate data, but that are private. So that's why, and it is done by creating those virtual tunnels. So that's why it is called virtual. It is private, and how we make it private is that we use the encryption technologies to keep that data that being transported through the public network secure by using those encryption methodologies. So that's why we call it virtual private networks or VPN. So it is still using the public infrastructure, but it is creating those tunnels, those private tunnels, to communicate confidential data between the end user and another end user or a site. So that's why we call it virtual private network. It is virtual because that it carries information within a private network, but it is still using the public network to do it. So it is a virtual network within the private network that is within the public network. So it is using the public network to build that virtual infrastructure. And it is private because we are using encryption with the VPNs so that the data will be confidential. So in this example on the right hand side, you have a Cisco business partner with a Cisco router, a regional office with a Cisco ASA firewall, a home office with a Cisco router, and a remote mobile worker with a Cisco AnyConnect client. And all of these end users or end systems are using those VPN tunnels to connect to the main site. So they are using the public internet, but on that public internet, these virtual tunnels are created with the encryption added to it, hence creating those VPN connections between the end user and the main site, securing the data between the two. So this is how the term virtual private networks come into play. So what you need to understand is why we call virtual private networks. So this is explain exactly that. So what are the benefits of VPN? Modern VPNs now support encryption features such as Internet Protocol Security, also known as IPsec, and Secure Socket Layer, also known as SSL. And those type of encryption will secure the network traffic between sites when you are using VPNs. There are few major benefits of using VPNs, and they are shown here on the bottom of your screen. They include their cost savings. So the organizations can use VPNs to reduce their connectivity cost while simultaneously increasing remote connection bandwidth. Because we are using the public internet infrastructure with VPNs, we can actually use those infrastructures bandwidth capabilities while using the VPN technology, hence reducing the cost. So there is no need to use like dedicated T1 lines, for example. especially with the site-to-site VPN connections. You can simply use the existing public internet infrastructure even with the site-to-site VPN, because it's save money in terms of how you're going to deploy that. So that's one of the advantage of VPN. Another advantage is security. Encryption and authentication protocols that we use with VPN protect data from unauthorized access. So as opposed to just using something like RDP, which is remote desktop system that used by Windows machines, they are usually unencrypted data. With VPN, what happen is, because we are using IPsec and SSL, the data will be secured, because the VPN inherently have that security built into the protocols. The next one is the scalability. So VPNs allow organizations to use the internet, the public internet, so making it easy to add new users without adding significant infrastructure onto it. So during COVID-19, for example, Cisco AnyConnect clients are being used by many companies, a lot of companies around the world, because you can simply install the Cisco AnyConnect client to a remote system, such as a laptop computer or even a desktop computer that a user own, and then you can configure that Cisco AnyConnect so that user can connect to your company's private infrastructure over the internet. So the scalability is very simple. You don't need a specialized dedicated line going to your remote worker's house. Because you can simply use the VPN for that remote worker so that they can connect to your company's network infrastructure, right? So you don't need to invest money on the network infrastructure more than just making sure that you implement those client on the end device. That's all you need to do. You just install the Cisco AnyConnect and configure it on any mobile device, and you're good to go. You don't need to have those dedicated lines. So scalability is very easy. So especially during COVID-19, I've seen a lot of companies have sent hundreds of their workers home and to work from home, and they all use this VPN connection to connect to their corporate networks. The next one is the compatibility. VPNs can be implemented across a wide variety of WAN link options, including broadband technologies. Remote workers can use these high-speed connections to gain secure access to corporate networks. So if you have workers with the broadband technology internet, such as like the Ethernet, such as cable internet, it doesn't matter which service provider they go with or what kind of packages they have. As long as there is enough bandwidth available for your company's need, your remote worker can access your company's network using the VPN, and hence making it very compatible with almost anything. So even satellite internet can be used with VPN to access the internet. In fact, you can use VPN on public Wi-Fi networks to secure your data. So it is very compatible, very flexible, very scalable, it's secure, and it also saves costs. So that's those are key benefits of using VPN. So let's look at site-to-site and remote access VPNs. A site-to-site VPN is terminated on VPN gateways. VPN traffic is only encrypted between those gateways, and the internal hosts have no knowledge of that VPN is being used. So imagine you have two sites. Let's say you have a site in Calgary and you have a site in Edmonton. So you have hundreds of users in Calgary and you have, let's say, 50 to 60 users in Edmonton. So you can have two VPN gateways on each site that is creating this tunnel between your two branches, one in Calgary, one in Edmonton. But whoever the users, in this case, let's say your company employees in Calgary, they wouldn't know that they are connected to a VPN because they are simply connected into the VPN gateway. And the VPN gateway is basically doing all the work that required to create that tunnel. So basically, the traffic is only encrypted between Calgary and Edmonton VPN gateways, but not encrypted between the gateway and your end user because there is no need for it. So the internal host have no knowledge that the VPN is being used. They're just connecting to your company corporate network, just like they're connecting to any other internet services. But however, because you have these VPN gateways set up, what happens is whenever the user is accessing data from Edmonton office from Calgary, it is actually going through the VPN tunnels because we have those VPN gateway set up. So you can look at that as like a having a edge of your network, you having a VPN gateway set up. So it's like a having all data every single time trying to exit your LAN, it will be encrypted because it's we are using the site-to-site VPN connection. Remote access VPN is dynamically created to establish a secure connection between a client and a VPN terminating device. In that situation, the client or the end user will be directly using the VPN tunnel to connect to a VPN gateway that is located in a remote location. So in that situation, the client would know that it is actually using VPN to connect to the system. So the client would have a software like a Cisco AnyConnect, for example, and the client would be connecting with the credentials for that VPN tunnel in order to get connection to that VPN gateway. So this is an important concept that you should understand. So in the previous one, in the site-to-site connection, the client simply connect to the gateway and the client doesn't know it's using the VPN, but the gateway is handling the connection between the remote sites, right? The gateway to gateway communication will be encrypted using a VPN tunnel, but the client is simply connecting to the VPN gateway and doesn't need to do anything special to get access to that system. But in the remote access VPN situation, the client is directly connecting to the VPN gateway that is located in a remote location. In that situation, the client have to initiate the VPN connection to create that tunnel. So in that situation, every single client gonna create that connection to that VPN gateway each time those clients connect to that remote site. This is the most common situation you will see during the COVID-19 period, where we have sent hundreds of employees home so that they can work from home. They actually have a client initiation VPN connection where they go home and plug it into their home general purpose internet connection, but then they're going to initiate the VPN connection from their device, so they will have access to the corporate network drives and secured devices such as printers, as well as file servers, as well as the corporate applications. So the client would initiate it from home using that client connection and to a VPN gateway. So unless your company actually sent your workers with VPN gateways that they need to put behind their internet connection, most likely in 99% of the cases in Canada, this is how the remote workers would connect. It is going to be the remote access VPN, not the site-to-site VPN. So site-to-site VPN in most situations where we have two VPN gateways are used when you are connecting different campuses or different sites within your organizations, as opposed to letting people go home during COVID. So they are usually the client initiation VPN connections. Enterprise and service provider VPNs. So VPNs can be managed and deployed as enterprise VPNs or service provider VPNs as well. So in enterprise VPN situation, that is a common solution for securing enterprise traffic across the internet. Site-to-site and remote access VPNs are created and managed by the enterprise using IPsec and SSL VPN. So in this situation, for example, if you have a company that are sending people home to work from home, they can create their own enterprise VPN network, and using that, you can secure the data. The service provider VPNs, in that situation, they are created and managed by the provider of the network. The provider uses the multi-protocol label switching, also known as MPLS, at layer 2 or layer 3 to create secure channels between an enterprise sites, effectively segregating the traffic from other customers. So basically, in this situation, instead of a single entity or single company creating that enterprise VPN infrastructure, like a network, what's going to happen is a service provider going to create and manage the VPN, and they're going to use something like MPLS, which is the multi-protocol label switching at layer 2 or layer 3 for securing and effectively separating data from other users. So that's how that's going to happen. So make sure that you know the difference between the enterprise VPN and the service provider VPN. On the right hand side, there is a brief summary of that in a graphical format. So you can see the enterprise managed VPNs have site-to-site option, as well as the remote access VPN option. Remember, I already explained how site-to-site works. So they use IPsec, GRE over IPsec, Cisco Dynamic Multipoint Virtual Private Network, also known as DMVPN, and IPsec Virtual Tunnel Interface, VTI. So those are the options that they have. And for the remote access VPN, we have the client-based IPsec VPN connection or client-less SSL connection. So either or would work. And this is where things like Cisco Any Connect software come into play. That's where the remote access basically is a software that you install on your end device, such as a Windows computer or a laptop, and then your user can then connect to the VPN using that software. And on the right hand side, we have the service provider managed VPN summarized in a graphical format. It is layer 2 MPLS or layer 3 MPLS. Either or would work. Also, the legacy solution would be the frame relay and ATM, which I would not think would be used in 2022, but you should know they do exist. So these are two types of enterprise and service. These are the enterprise and service provider VPNs. Those are the two types you should be familiar with. Types of VPNs. Remote access VPNs. So the remote access VPNs, as I mentioned previously briefly, let remote and mobile users securely connect to the enterprise network. Remote access VPNs are typically enabled dynamically by the user when required and can be created using either IPsec or SSL. So it's dynamically, typically it's a dynamically created. So when the user needed to have the VPN connection, they can just connect it. So the clientless VPN connection is a situation where the connection is secured using a web browser SSL connection. So basically they would have the end user will connect to the network and go to a web browser, and that will allow you to connect to the VPN tunnel. The client-based VPN connection is a VPN client software such as Cisco Any Connect, secure mobility client. They use that client that has to be installed on the end user's device in order to connect to that VPN tunnel. So the client-less use the web-based authentication. Client-based use a software-based authentication where you need to have the VPN software installed on the end device to connect. But please keep in mind both client in this specifically the client-based VPN connection, it can use both SSL as well as IPsec to connect. But in the client-less connection, typically in most of the time, it's just SSL because that's the only one that the web browser can use. So if your organization is using a client-based VPN connection, which is like a Cisco Any Connect, the user would have the option to use either SSL security or IPsec unless you disable one of them. So it should be the user could use either one of them. So at the end of the day, whether the user is using the computer with a web-based VPN connection or the computer with the type of a Cisco Any Connect type of software, they would be still creating the similar type of VPN SSL tunnel or the IPsec tunnel that would allow you to connect to the headquarters network. SSL VPNs. So SSL uses the public key infrastructure and digital certificates to authenticate peers. The type of VPN method implemented is based on the access requirements of the users and the organization's IT processes. The table on the bottom of your screen compares IPsec and SSL remote access deployment. So on the right hand side, we have the features associated with the IPsec and SSL, and then the left hand side it describes how it is differ from each other. So application supported. IPsec is extensive. All IP based applications are almost guaranteed to be supported on IPsec. SSL, however, the application support is limited. So only web-based applications and file sharing systems will be supported in SSL, and your organization may have some some ways to mitigate this. Like you can still use the SSL and still use some of the softwares, but it is very limited, and it needs to be specifically configured if there's any other software that needs to use those SSL. But IPsec, almost all IP-based application would work on IPsec. Authentication strength. IPsec is extremely strong. It is one of the strongest authentication systems we have today. There is a two-way authentication with the shared keys or digital certificates that you can associate with that. So you can actually add on to a general purpose IPsec with some other third-party digital certificate key sharing software that would allow you to use a very strong authentication system. SSL, however, is moderate because it is usually one-way or two-way authentication, but the security is moderate compared to IPsec. Encryption strength. IPsec is very strong because the key length is 56 to 256 bit, and most companies that really need that security will use the 256 bits encryption on IPsec. However, the SSL key strength can also go from 40 all the way to 256 bits. So depending on how your organization deploy the SSL, it could either be moderate or it could be very strong. So if in this situation with the encryption, if you use SSL with 256-bit encryption, it will be as almost secure as the IPsec, but you need to implement that accordingly. Connection complexity. IPsec is kind of medium complexity, so it requires a VPN client installed on the host, such as Cisco AnyConnect, as I mentioned before. While the SSL is low because it requires just a web browser on a host. Again, just to keep in mind that the Cisco AnyConnect do allow SSL methodology to be used, even though it's using the SSL client. So in SSL, it must have the web browser based connectivity system, but with Cisco AnyConnect, you can use the SSL methodology but using a client as well. But for IPsec to work, it requires the VPN client to be installed, right? Remember that. The connection options, well, the IPsec is limited because only specific devices with specific configuration can connect. So when you install that Cisco AnyConnect software onto your end clients, you need to configure that so that the software will work with your network. So your the system that you have configured for your VPN. SSL, however, is extensive. There are a lot of extensive connections. So any device with the web browser pretty much can connect to an SSL network if it is properly configured. Site-to-site IPsec VPNs. Site-to-site VPNs connect networks across an untrusted network such as the internet. Each host send and receive normal unencrypted TCP IP traffic through a VPN gateway. So what that means is basically when this host communicated out to the internet, out to this the other site, the data between this device and the VPN gateway would be unencrypted. So this device wouldn't even know that it is using VPN, because it's just going to send the TCP IP traffic to this gateway. However, the VPN gateway encapsulates and encrypts outbound traffic from a site and sends the traffic through the VPN tunnel to the VPN gateway at the target site. So then the receiving VPN gateway strips the headers, decrypts the content, and relays the packet towards the target host inside its private network. So basically, the data between the end user and the VPN gateway is simple unencrypted TCP IP traffic. But when it reaches the gateway and the data needs to go out, the VPN gateway gonna then encrypt that data before it's sending out to the other VPN gateway on the remote site. So that's how the site-to-site IPsec VPNs work. So the hosts can send and receive normal unencrypted TCP IP traffic through that VPN gateway. The gateway do all this the encryption and decryption and everything, so that it can communicate across the internet, as well as the communicate to the devices behind that gateway. So any devices behind this VPN gateway is unencrypted. Any data that goes across the internet through the remote site to the next gateway will be encrypted. So the site-to-site tunnel works that way. So you have a gateway on one side, gateway on the other side, and the data communication between the gateways will be site-to-site IPsec VPN. GRE over IPsec. Generic routing encapsulation, also known as GRE, is a non-secure site-to-site VPN tunneling protocol. This is a key piece of information that is very important that you understand, because this will show up on your exams and you will get confused and pick the wrong answer. Generic routing encapsulation, or GRE, is not an encryption methodology. It is a non-secure site-to-site VPN tunneling protocol. So GRE is a tunneling protocol. It is not an encryption methodology or encryption system. It is a tunneling protocol. So the GRE, again, remember, it is a non-secure site-to-site VPN tunneling protocol. A GRE tunnel can encapsulate, however, various network layer protocols as well as multicast and broadcast traffic. GRE does not by default support encryption, and therefore it does not provide a secure VPN tunnel. A GRE packet can be encapsulated into an IPsec packet to forward it securely to the destination VPN gateway. So you can use GRE in a combination of IPsec in order to secure that data. A standard IPsec VPNs, which are non-GRE, can only create secure tunnels for unicast traffic. So encapsulating GRE into IPsec allows multicast routing protocol updates to be secure through VPN. So if somebody asks you in an exam, why do we even use GRE if it is just a tunneling protocol that doesn't have security? The reason is that we are using GRE with a combination of IPsec because the standard IPsec VPNs can only create secure tunnels for unicast. By using the GRE encapsulation methodologies and then using it with the IPsec allows us to use both multicast and unicast data to be routed through a secure VPN tunnel. So GRE is a non-secure site-to-site VPN tunneling protocol, but the GRE in a combination of IPsec security can be used for multicast and unicast communication through a VPN tunnel. The terms used to describe the encapsulation of GRE over IPsec tunnels are passenger protocol, carrier protocol, and transport protocol. So those are three terms that you should be familiar with. So what are they? So the passenger protocol, this is the original packet that is to be encapsulated by the GRE. It could be an IPv4 or IPv6 packet, a routing update, or in anything else associated with that type of packets, right? So it is the original packet that is to be encapsulated. It is called the passenger protocol. Carrier protocol is the GRE is the carrier protocol that encapsulates the original packet. So remember, GRE is a tunneling protocol, right? So think about that way. So it is very easy to understand this because it's a simple English. It's carrier, it's carrying data. So basically GRE is the carrier protocol because that is the one that's going to carry that data, right? Encapsulate the original packet. So that is GRE going to be the carrier protocol. Transport protocol, this is the protocol that will actually be used to forward the packet. This could be IPv4 and IPv6 as well. So the transport protocol is the actual transportation protocol. So you should actually know what they are and how they are differ from each other. So what is the, if your instructor asks you, or if the Cisco exam asks you, what is the difference between a passenger protocol and a transport protocol, you should be able to tell me that, right? And you should know that the GRE over IPsec tunnel have those passenger protocol, carrier protocol, and transport protocol. On the bottom of your screen, this is basically showing how, you know, the packet would be divided, the frame or the packet would be divided. So we have the IP, which is the transport protocol, GRA would be the carrier protocol, and then the passenger protocol include the IP, TCP, and the data associated with it. So you should know this by heart, so that you'll be able to write those exams and understand the concepts that we will be covering. So for example, the branch and head office, or HQ, needs to exchange OSPF routing information over an IPsec VPN. GRE over IPsec is used to transport the routing protocol traffic over the IPsec VPN in this example shown here. Specifically, the OSPF packets, these are like the passenger protocol, would be encapsulated by GRE, which is the carrier protocol, and subsequently encapsulated in an IPsec VPN tunnel. So right here we have a switch associated with this branch, and we have a head office, and we have a switch associated with that head office router. So we have a branch router and you have a head office router, and we have switches associated on either side connecting different devices. Now they need to communicate. So these two routers basically gonna do the IPsec, GRE over IPsec, so that this tunneling will be created. And you will have the original packet, you have the GRE tunnel, and you have the IPsec VPN tunnel. So you can look this thing as a way that how it is being layered. So you have the original IP packet in the center, which is being protected by the GRE tunnel, which is being protected by the IPsec VPN. So you can look at that way, even though it's like a weird way of looking at it. So you can look it that way. So it's like you can think it of a layered security. So you have the origin. So if you don't have any of the security, it will be the original packet that going across the internet. But now we have the original packet, but it is protected by the GRE tunnel, and it is also protected by the IPsec VPN system. So it basically creating those layered security type of method. You have the multiple security being applied so that the data across the branch and the HQ will be secured. So that's how the GRE over IPsec works. Dynamic multi-point VPNs. Site-to-site IPsec VPNs and GRE over IPsec are not sufficient when the enterprise adds many more sites. Dynamic multi-point VPN, also known as DMVPN, is a Cisco software solution for binding multiple VPNs in an easy, dynamic, and scalable manner. So one of the key things you should understand here is that the DMVPN is a Cisco proprietary system. So that is one of the key things that may be asked during your exams. And what it does is that when you have an enterprise level network with many sites, the IPsec VPNs and GRE over IPsec is not good enough. So it's not very scalable. So DMVPN address that issue. So that's the key feature of DMVPN. However, it is a Cisco proprietary system. So DMVPN simplifies the VPN tunnel configuration and provides a flexible option to connect a central site with branch sites. It uses a hub and spoke configuration to establish a full mesh topology. Spoke sites establish secure VPN tunnels with the hub site. Each site is configured using multi-point generic routing encapsulation, also known as MGR, and the MGR tunnel interface allows a single GER interface to dynamically support multiple IPsec tunnels. So remember that the MGER tunnel interface allows a single GER interface to dynamically support multiple IPsec tunnels. Spoke sites can also obtain information about each other and alternatively build direct tunnels between themselves, known as the spoke-to-spoke tunnels. So the spoke site can also obtain the information about each other and then build their own tunnels. They are called the spoke-to-spoke tunnels. So that's how the DMVPN works. IPsec Virtual Tunnel Interface. So IPsec Virtual Tunnel Interface, also known as VTI, simplifies the configuration process required to support multiple sites and remote access. IPsec VTI configurations are applied to a virtual interface instead of a static mapping of the IPsec sessions to a physical interface. So the interfaces would be virtual. That's what the Virtual Tunnel Interface, or VTI, stand for. So the IPsec VTI is capable of sending and receiving both IP unicast and multicast encrypted traffic. Therefore, the routing protocols are automatically supported without having to configure GRE tunnels. So because the VTI, the virtual tunneling interface, is capable of sending and receiving both unicast and multicast messages, the routing protocols are automatically supported without having to configure the GRE tunnels. IPsec VTI can be configured between sites or in hub and spoke topology. So if you have a branch site and the head office site, you can create those VTIs so that the traffic enter an interface here, and then the packet are routed to the VTI, and then the VTI encrypts and forwards the encrypted packet to the physical exit interface of that branch router, and it goes into the HQ router. So that's how the IPsec VTI would work. Service provider MPLS VPNs. Today, service providers use MPLS in their core network. Traffic is forwarded through the MPLS backbone using labels. Traffic is secure because the service provider customers cannot see each other's traffic. So the MPLS is used by service providers to separate traffic between customers. MPLS can provide client with managed VPN solutions. Therefore, securing traffic between the client sites is the responsibility of the service provider. So there are two types of MPLS VPN solutions supported by the service providers. They include Layer 3 MPLS VPN and Layer 2 MPLS VPNs. In the Layer 3 situation, the service provider participates in customer routing by establishing a peering between the customer's routers and the provider's router. So they're going to create a peer connection between the two. In Layer 2 MPLS VPN, the service provider is not involved in the customer routing. Instead, the provider deploys a virtual private LAN service, also known as VPLS, to emulate an Ethernet multi-access LAN segment over MPLS network. No routing is involved in this situation. The customer's routers effectively belong to the same multi-access network. So these are the two types that you should be familiar with, which we won't go into depth in this course, but you should know these two exist. IPsec. So there's a video from Cisco called IPsec Concepts. If you have access to it through Cisco NetAcad, please go ahead and watch it. But if you do not, I have a copy of that posted to my YouTube channel, and I will leave a link in the description, as well as I will leave a card on the top right hand corner, so you can go ahead and click it and watch it. I would recommend that you watch this video first before we move forward into the next few slides. IPsec technologies. IPsec is an IETF standard that defines how a VPN can be secured across IP networks. IPsec protects and authenticates IP packets between source and destination and provides these essential security functions. They include the confidentiality, integrity, origin authentication, and Diffie-Hellman. So it provides, the IPsec provide confidentiality because it uses encryption algorithms to prevent cyber criminals from reading the packet contents. It provides integrity because uses hashing algorithms to ensure that the packet have not been altered between the source and destination. So during the transit, if there is some kind of altering of the data, the IPsec would be able to pick that up. Origin authentication, it uses the Internet Key Exchange, also known as IKE protocols, to authenticate source and destination. So it provides that type of the origin authentication support. Diffie-Hellman, remember I have introduced you briefly to Diffie-Hellman in my previous module. So that type of security, the Diffie-Hellman secure key exchange security, is also being used by the IPsec. So the IPsec used the Diffie-Hellman for its secure key exchange. IPsec is not bound to any specific rules for secure communications. IPsec can easily integrate new security technologies without updating existing IPsec standards. The open slots in the IPsec framework, shown in the figure on the right hand side, can be filled with any of the choices that are available for the IPsec function to create a unique security association, also known as SA. SA is a unique security association. So that is a really flexible way of implementing something, right? Because IPsec is not bounded to any specific rules for securing communication. You can use the other methodologies to secure your data and communication within the IPsec framework. So if you look at the right hand side, we have the IPsec protocol, and you have these choices you can pick, and there are some empty areas that you can come up with. And then the confidentiality is the same way. You have all of these choices you can use. Same with the integrity, you can use MD5 or SHA. Authentication, you can use PSK or RSA. Diffie-Hellman, you have Diffie-Hellman 1, 2, 5, or keep going. So you can actually have many choices within the implementation of IPsec and how you're going to secure your corporate network. IPsec protocol encapsulation. So now we are looking at the IPsec protocol up here. So choosing the IPsec protocol encapsulation is the first building block of that framework. So IPsec encapsulate packets using authentication header, also known as HA, or encapsulation security protocol, also known as ESP. The choice of HA or ESP establishes which other building blocks are available. HA is appropriate only when confidentiality is not required or permitted, while the ESP provides both confidentiality and authentication. So in most situations, you should be using ESP over AH as the choice here. But however, authentication header may be, or the AH may be used when confidentiality is not required, or in some situations not permitted. So that's why you pick that one. But in most cases, 99% of the cases nowadays, you will be using the encapsulation secure protocol ESP, which provide both confidentiality and authentication. So that's the first thing we're going to do in the selecting configuring the IPsec protocols. So let's look at the confidentiality. the degree of confidentiality depends on the encryption algorithm and the length of the key used in the encryption algorithm. So in my previous module, I mentioned how the longer key length is harder to crack, but however it takes more CPU usage, RAM usage, and sometimes even more time to decrypt and encrypt. So remember, keep that in mind, in your back of your mind. So the length of the key used in the encryption algorithm do play a degree of how confidential data going to be. So the number of possibilities to try to hack the key is a function of the length of the key. So therefore, the shorter the key, easier it is to break. So longer keys make it harder for the bad guy or the threat actor to decrypt that data unethically, because the keys, it takes longer for them to try to hack it. The encryption algorithms highlighted in the figure are all symmetric key crypto systems. So on the right hand side, we have DES, 3DES, AES, and SCL or SEAL, SEAL. They are all symmetric key crypto systems. So the DES uses a 56-bit key, 3DES use 3 independent 56-bit key encryption, therefore 64-bit per block, but 56-bit encryption keys. AES offers 3 different key lengths that includes the 128-bit, 192-bit, and 256-bit. So the AES have more options available, and the 256-bit going to be the most secure out of all these 3 options. SEAL or SEAL is a stream cipher, which means it encrypts data continuously rather than encrypting blocks of data. The SEAL uses 160-bit key. So in that case, it is using stream, it's a stream cipher. So instead of up here, they are using blocks of data. This is actually continuously encrypting data, and it uses 160-bit key to do that. So next, we're going to look at the integrity. So data integrity means that the data has not changed in transit. So it's like a fingerprinting something. A method of providing data integrity is required. So the hash message authentication code, also known as HMAC, is a data integrity algorithm that guarantees the integrity of the message using a hash value. So that's a type of way. It's like a fingerprint. The hash value is like a fingerprint, just to make sure that the data is good on both ends. So the data that's been sent from the originator is the same as the receiving end. The message digest 5, also known as MD5, uses a 128-bit shared secret key, while the secure hash algorithm, also known as SHA, uses a 160-bit secret key. So you have the option of using either MD5 or SHA for securing your data, like the checking your integrity of your data in the IPsec tunnels. Authentication. There are 2 IPsec peer authentication methods. They are the PSK and RSA. PSK is the pre-shared key method, where the value is entered into each peer manually. Easy to configure this system and does not scale very well, because you need to be manually enter that information to each peer, and must be configured on every peer. So because of that, it is not very easy to scale. The RSA method, which is reverse Schemmer and Alderman method, also known as RSA in short, authentication in this situation uses digital certificates to authenticate the peers. So each peer must authenticate its opposite peer before the tunnel is considered secure. So in this situation, we have certificates, digital certificate on the either end of the system, where those certificates are used by each peer to authenticate itself to the opposite peer before the tunnel is considered secure. So this is much easy to scale compared to the PSK method. Secure key exchange with Diffie-Hellman. So I have introduced how Diffie-Hellman works on my previous module. If you haven't watched those modules, please go back onto my YouTube channel and check one of the items that I have described the Diffie-Hellman. In the future, I will try to create a separate video also on Diffie-Hellman and how it works and post to my YouTube channel, because this is a very important concept in understanding how VPN works, because Diffie-Hellman is used a lot in most of the VPN infrastructure in modern days. So here's how a brief overview of how we secure key exchange with Diffie-Hellman. So DH or Diffie-Hellman providers allow two peers to establish a shared key over an insecure channel. Variations of the DH key exchange are specified as DH groups described on the right hand side right here with this diagram: DH1, DH2, DH5, etc., etc. So the DH groups 1, 2 and 5 should no longer be used because it is considered as insecure by now. But the DH group 14, 15 and 16 use larger key sizes with 2048 bits, 3072 bits and 4096 bits respectively. So the DH group 14, 15, 16 are more secure. The DH group 19, 20, 21 and 24 with respective key sizes of 256 bits, 384 bits and 521 bits and 2048 bits support elliptical curve cryptography, also known as ECC, which reduces the time needed to generate keys. So these are like different DH groups and how they are differ from each other. For now, for this course, just know what these groups are. Make sure you remember not to that we shouldn't use the group 1, 2 and 5, and also you should know the DH group 14, 15, 16, group 19, 20, 21 and 24, and how they are differ from each other. So for your exams, if the Cisco quizzes or exams ask you, okay, which are the elliptical cryptography groups, right, DH groups, you should be able to pick 19, 20, 21 and 24, as opposed to 14, 15 and 16 does not have that the ECC capability. So you should know those things, and you should also know the DH group 1, 2 and 5 should not be used anymore. So these are the things that you should know for exams and quizzes just for now, but with the labs and other things we're going to do, we will learn a little bit more about how we can configure these as well. So there's another video called IPsec transport and tunnel mode. If you have access to this through your Cisco NetAcad, please go ahead and watch there. But if you do not have access to it, I have a copy of this video that I have posted to my YouTube channel. So I will leave a link in the description as well as a card on the top right hand corner, so you can click on it and watch that video. And that would bring us to the end of this lecture. And next we will go over what we have covered. We learn a VPN is a private in that the traffic is encrypted to keep the data confidential while it is transported across the public network. Benefits of VPNs are cost savings, security, scalability, and compatibility. Remote access VPNs let remote and mobile users securely connect to the enterprise by creating an encrypted tunnel, and remote access VPNs can be created using either IPsec or SSL. We learned site-to-site VPNs are used to connect networks across an untrusted network such as the internet. In a site-to-site VPN, host and receive normal unencrypted TCP/IP through a VPN terminating device. Remember that. In a site-to-site VPN, the host sends and receives normal unencrypted TCP/IP traffic through a VPN terminating device. VPN terminating device is typically called a VPN gateway. GRE is a non-secure site-to-site VPN tunneling protocol. However, you can use GRE along with IPsec to secure those GRE tunnels. DMVPN is a Cisco software solution for easily building multiple dynamic scalable VPNs. We learn like DMVPNs, IPsec VTI simplifies the configuration process required to support multiple sites and remote access as well. We also learn IPsec protects and authenticates IP packets between the source and destination. IPsec can protect traffic from layer 4 through all the way to layer 7. Using the IPsec framework, IPsec provides confidentiality, integrity, origin authentication, and Diffie-Hellman. IPsec encapsulates packets using AH or ESP. We also learn the degree of confidentiality depends on the encryption algorithm and the length of the key used in encryption algorithm. So longer the length, the stronger the encryption going to be. DH provides a way for two peers to establish a shared secret key that only they know, even though they're communicating over an insecure tunnel. So remember that. The DH provides a way for two peers to establish shared key secret key that only they would know, even though they are communicating that over an insecure tunnel. And that would bring us to the end of this module. If you like these type of lectures, please thumbs up this video and subscribe to my channel. I know I have gone over a lot of theory concepts associated with VPN, but in the near future, I will go over some Cisco lab demonstrations and post to my YouTube channel so you can have a better understanding of the concepts that we have covered. If you have any questions, don't hesitate to reach out to me. Until next time, good luck and have a nice day.